Hey folks, I thought I would just go through this handout with you guys quickly here. So let's take a look at the first question. First question, write an addition statement to show the relationship of the squares, and then use words to describe the relationships of them. Okay, probably won't do that, but let's take a look at A here. Now, in a right triangle, this is a right triangle because it has this little 90-degree angle here. In any right triangle, so a triangle that has a 90-degree angle, if we add the squares of the two short sides, so like D times D gives us R, this area of this square, and E times E gives us S, the area of this square. When we add those together, the S plus the R, we will get the area, or the squared dimension of this longest side on the triangle. So S plus R has to equal T in every right triangle. S plus R equals T. Okay? Let's look at number 2 here. What are the areas of the squares in the diagram? So basically, if we know this side length is 10, this one is 6, and this bottom one is 8, then the area of those squares is, we just multiply them by themselves. So the area of that square would be 36, because 6 times 6 is 36. This one would be 64, 8 times 8, and this one would be 100. Now, let's use some units here. Let's get all proper. Meters squared. B, write 2 addition statements to show the relationship between the squares. So just as in the first question at the top there, K plus J has to equal L. Also, if we look at the side lengths themselves, 8 squared plus 6 squared has to equal 10 squared. And you'll notice it does. Okay, if we look back up here, 64 plus 36 is 100. So because that happens, 64 plus 36 gives us this 100, and that's what it's labeled as, 10, 8, and 6. That means this is, in fact, a right triangle. Okay. Number 3, complete the table using information provided in the diagram below. So we've got the area of the square. Oh, okay, so we're just going to fill in the let's start with the smallest one. So 64, and then the other one is 225, and then the bottom one is 289. So this is our hypotenuse, and then these two are the legs, okay? And to find so if we know the area of the square and we're trying to find the side length, we just square root these, okay? So the square, meaning what number do I multiply by itself to get 64? What number do I multiply by itself to get 225, and so on? So you should either know those, because we talked about the perfect squares before spring break, or if you're not sure, you can just take the square root of them, and you would get, in this case, 8. In this case, you would get, what is that, 15? And in this case, square root of 289 is 17. There we go. Okay, on to the next page. Okay, on to the next page here. Don't worry about that. We've already done that. Lots on the front. Number 4, the sides of a right triangle are 15, 20, and 25. What's the area of each square? This one is 225 centimeters squared. This one is 400 centimeters squared. And this last one here would be 625 centimeters squared. So the hypotenuse, the longest side, would be the longest, or the largest area, and it means the 2 legs have to add up to this. So sure enough, 225 plus 400 is 625, so we're good to go. Let's skip the next one. Number 5, is the triangle below a right triangle? Explain your reasoning. Okay, so if it is a right triangle, see, we're not sure, there's a question mark there. It means the hypotenuse, okay, this is the longest side, it means that the two smaller ones, 14,400 plus 2,500, has to equal this one, okay? So when we do a quick number crunch here, they do add up. So this plus this has to equal this. So 14,400 plus 2,500. When we add them up, we do get 16,900. So because this relationship exists, yes, it is a right triangle, which basically tells us that this little angle right here is in fact 90 degrees. So we're good to go. Number 6, let's see here. Okay, so if it's a right triangle, this plus this has to equal that. So 25 plus 36 has to equal that. And it is 25 plus 36 is 61 centimeters squared. This one up here, if we look at it for B, again, you got to be careful. It's always the two small ones that add up to the big one. So I can't just go, oh, add these two and get that. No, that doesn't make sense. This is the biggest one. So what would I have to add to 49 to get 100? 51. So that one's 51 centimeters squared. Okay, and this one here down in the corner is that. What's the area of the square on side T of each triangle? So they're breaking it down, or they're taking it one step further here. So this one, the square on the side would be 49 centimeters squared. The square on the side of this one would be 81 centimeters squared. And when we add those together, it would have to give us the hypotenuse, the square on the side of the hypotenuse. So 49 plus 81 is 130 centimeters squared. Okay, this one we would have 225 millimeters squared and 16 millimeters squared. So when we add those two together, we would get 241 millimeters squared. Okay, that's what it would be. Number 8, Jeremy wants to make sure that the walls he's building are at right angles. So he wants to make sure that this is a 90-degree angle in this corner. He measures and marks 3 meters along wall A. Okay, so from the bottom up. And, oh, I guess this is top view. So he walks from this corner that way 3 meters and this way 4 meters. And he marks a distance. The distance between the two marks is 5 meters. So is this a 90-degree angle? Yes, it is, because if we just draw it a little bit easier to see here, if this is 4 and this is 3 and this is 5, when we square the two legs, so that's 9, 3 times 3, and that's 16. Do we get 5 squared? In other words, do we get 25? 9 plus 16 is, oops, it's 24. Is 25. So yes, he's good to go. All right, folks. Hopefully that was helpful. We'll get some more work tomorrow. We'll see how the weekend goes, and hope all is well with you guys at home. Of course, if you ever need to get a hold of me, my email address is snooby@epsb.ca. Bye for now.